Welcome to Spring LIB.
For this question, we're interested in the particular fission reaction of uranium-235. Now, the first part of this question, we want to identify what is the unknown X. And to do that, we will need to use the conservation of the proton number and nucleon number. So on the left-hand side, we have a total proton number of 92. On the right-hand side, we must have proton number of 92 as well, in total. So we know that strontium takes up 38, so 92 minus 38 is 54. Now the neutrons don't contribute any proton number, so X must have the proton number of 54. We do the same process for the nucleon number. So on the left hand side we have 236, total nucleon number. On the right we take 236, subtract away 92 from the strontium, and subtract away 3 from the neutrons. So we should get 141. And by looking up the periodic table for an element with 54 protons, we find that this is xenon. So this element must be xenon 141. Now the next part, we are looking at the nuclear reactor operating on this particular fission reaction, but running at barely critical. So barely critical means that one of the nuclear fission would result in another nuclear fission, only one other nuclear fission. So the chain reaction is 1:1, right? So it goes on from one nuclear reaction to another. But we know that in this case we have 3 neutrons that are being produced that could result in 3 fission reactions, right? Because each fission reaction only takes up 1 neutron. So what this means is that 2 of the other neutrons must be absorbed away or taken away so that it doesn't produce fission reaction, right? So this is usually absorbed by a control rod that will prevent the neutrons from undergoing further fission, and on average 1 out of the 3 neutrons should go on to create another fission reaction, right? And so this is what it means to be running at barely critical. Now to find the Q value of this reaction, we need the change in the masses of the nuclides, multiply that by C square. In this case, the change of nuclide, change of the mass, is referred to the mass of the initial reactants, subtract away the mass of the final products. So the initial masses are mass of the uranium 235, mass of the neutron, then we subtract away mass of the strontium 92, with mass of the xenon 141, and 3 times of the mass of our neutrons. Then we multiply everything by C square. So all these masses can be found using the online resource. So uranium-235 is over here. The mass of the neutron, mass of the strontium 92, mass of xenon 141 is here. So we have all the values that we need. The C square, we can use a value of 91.5 MeV per U, since we are dealing with atomic mass units. So it's more convenient for us to find the energy, right, in terms of MeV. So we just substitute the values into the calculator. We should get an answer of 176 MeV.